Reversible. Bismillahirrahmanirrahim. Reversible and irreversible processes. A reversible process is one which can be retraced in exactly reverse order without producing any change in the surrounding. In the reverse process, the working substance passes through the same stages as in the direct process, but thermal and mechanical effects at each stage are exactly reversed. If heat is observed in the direct process, it will be given out in the reverse process, and if work is done by the substance in the direct process, work will be done on the substance in the reverse process. Hence, the working substance is restored to its original condition. A, a succession of events which bring the system back to its initial condition is called a cycle. A reversible cycle is the one in which all the changes are reversible. Although no actual change is completely reversible, but the processes of liquefaction and evaporation of a substance performed slowly are practically reversible. Similarly, the slow compression of a gas in a cylinder is a reversible process, as the compression can be changed to expansion by slowly decreasing the pressure on the piston to reverse the operation. If a process cannot be retraced in the backward direction by reversing the controlling factors, it is an irreversible process. All changes which occur suddenly or which involve friction or dissipation of energy through conduction, convection, or radiation are reversible. An example of highly reversible process is the explosion. The system engine is a thermodynamic system. Heat engine. A heat engine converts some thermal energy to mechanical work. Usually, the heat comes from the burning of the fuel. The earliest heat engine was the steam engine. It was developed on the fact that when water is boiled in the vessel, converted convert with a lid, the steam inside tries to push the lid off slowly. The ability to do work. This observation helped to develop a steam engine. Basically, a heat engine consists of hot reservoir of source which can supply heat at high temperature, and a cold reservoir or sink into which heat is ejected at a lower temperature. A working substance is needed which when observed heat given from source convert some of it into work W by its expansion and rejects the rest heat Q2 to the cold reservoir. A sink. A heat engine is made cyclic to produce a continuous supply of work. Second law of thermodynamics. First law of thermodynamics tells us that heat energy can be converted into equivalent amount of work, but it is silent about the condition under which this conversion taken place. The second law is concerned with the circumstances in which heat can be converted into work and direction of flow of heat. Before initiating the discussion on formal statement of the second law of thermodynamics, let us analyze briefly the effectual operation of an engine. The engine or the system represented by the block diagram absorbs a quantity of heat Q1 from the heat source at temperature T1. It does work W and expels heat Q2 to the low temperature reservoir at temperature T2 as the working substance going goes through a Clean process in which the substance eventually returns to its initial state. The change in internal energy is zero, hence from the first law of thermodynamics, net work done should be equal to the net heat absorbed. W is equal to Q1 minus Q2. In practice, the petrol engine of a motor car extracts heat from the burning fuel and converts a fraction of this energy to mechanical energy or work and expels the rest to atmosphere. It has been observed that petrol engines convert roughly 25% and diesel engines 35 to 40% available heat energy into work. Second law of thermodynamics is a formal statement based on these observations. It can be stated in a number of different ways. According to Lord Kelvin's statement, based on the working of a heat engine, it is impossible to devise a process which may convert heat extracted from a single reservoir entirely into work without leaving any change in the working system. This means that a single heat reservoir, no matter how much energy it contains, can not be made to perform any work. This is true for ocean and our atmosphere, which contain a large amount of heat energy but can not be converted into useful mechanical work. As a consequence of second law of thermodynamics, two bodies at different temperature are essential for the conversion of the heat into work. Hence, for the working of heat engine, there must be a source of heat at a high temperature and a sink at low temperature to which heat may be expelled. The reason for our inability to utilize the heat contents of ocean and atmosphere is that there is no reservoir at a temperature lower than any one of the two. Tied by temperature T, heat energy engine work impossible. According to Kelvin's statement of second law of thermodynamics, the process pictured here is impossible. Heat from a source at a single temperature cannot be converted entirely into work. Here, hot reservoir T1 Q1 heat engine output work is equal to W Q2 cold reservoir T2. Schematic representation of engine. The engine absorbs heat Q1 from the hot reservoir, expels heat Q2 to the cold reservoir and does work W. Ya Allah.